Okay, this is rapid capacitance revision. So same rules apply. We reach for our formula sheet. So on our formula sheet, we're told that for a series capacitance circuit, so it works different for our resistors, that we got 1 over our total capacitance equals 1 over C1 plus 1 over C2. So we're going to have 1 over 48 farads plus 1 over 36 farads. So that's 7 over 144. So then if we flip that 1 over, then we end up with 20.6 farads. So we should have our capacitance should be no bigger than our small size capacitor. Right, okay, slowing down there. Okay, so total charge. So we know that charge is equal to voltage times by our capacitance, which is why we just worked out the total capacitance for our circuit. So we've got 24 volts times by 20.6 farads. Gives us 494.4 coulombs. Okay, the unit for charging is coulombs. If we were then working out energy, then we would be into joules. So the voltage across the 48 farad capacitor. So the same resistance circuit. So we're looking to know what the voltage across there is. So that 24 volts there is split across this capacitor and this capacitor, same as it would be with the with resistors. So we're just applying this equation here. So voltage is equal to charge divided by our capacitance. So we've got 494.4 divided by 48 farads, which is 10.3 volts. Now, interestingly, if we then do that same question again, so 10.3, if we then do it again for this 36, that voltage across that capacitor plus that one there should equal that voltage there. If it doesn't, then you've gone wrong. So you know where if there's an element to go wrong. Okay, so that was series. So let's look at capacitors in parallel. So capacitors in parallel, we're just going to add them up like so. So we're going to have 100 plus 200 plus 400, which equals 700 microfarads. Remembering that we're working in the microfarads. Total charge stored in the circuit. So charge is equal to voltage times capacitance. So we've got 140 volts multiplied by our 700 microfarads, which gives me 98 millicoulombs. Okay, happy days. Right, what's next? Okay, so a bit of an odd entity here. We need to have a bit of a scour around. Anything to do with electric field strength is found under the magnetism section. So you can probably hear me turning over the formula sheet. So we're looking for E, which is our potential difference, electric field, voltage divided by the distance. So what voltage we've got? 50 volts divided by our 20 millimeters. So 20 times by 10 to the minus 3 equals... Oh, that was a bit loud, wasn't it? 2,500. What's the unit? Well, that's volts, and we've converted our 20 millimeters into meters, so it's volts per meter. Okay, last one on capacitance. It's a toughie, but it's a goodie. So we want to know what the capacitance value is. So capacitance is equal to permittivity times by our area divided by our distance. Now, we need to remember that permittivity is equal to absolute multiplied by the relative permittivity. So when we write all that out from our formula sheet, 8.85 times by 10 to the minus 12 multiplied by our permittivity of our material, which is 10, so that's our relative permittivity, multiplied by our area. So our area, so we're converting 50 millimeters squared into meters squared, so 50 times by 10 to the minus 6, divided by the distance between the plates, so 0.6. Converting that into meters, so 10 times minus 3. Now, for those that are a bit confused, let me just take a moment to explain the 50 times 10 to the minus 6. So you could have 10 millimeters times by 5 millimeters is equal to our 50 millimeters squared. So if I write that out, 50 times 10 to the minus 3, so multiplying all of that out, so 10 times 5 is 50, and then multiplying our indices, they're going to add up, so times by 10 to the minus 6. So that's why when we convert millimeter squared to meter squared, it becomes to the minus 6. Okay, and then we just, all we've got to do then, now we've got all of that into our equation, is just type it all in, and we should end up with 7.375. Oh, can't write. 7.375 times 10 to the minus 12 farads. Now, for those that want to, you convert that minus 12 into pico, but otherwise, just leave it alone. Okay, that's it for the capacitors. Stand by for another video on AC or what's the other tip? Magnetism. Woohoo!